In this illustration, we'll calculate the strain energy in a stepped rod. We are given that a rod 1 meter long and 10 centimeter square cross-section in area for a portion of its length and 5 centimeter square cross-section for remaining length is pulled from both ends to develop a stress in it. And the strain energy in this stepped rod is 40% of that, a rod of 1 meter length and uniform area of 10 centimeter square when subjected to the same maximum stress in the stepped rod. And we are required to now find the length of portion of 10 centimeter square area in the stepped bar. Now here we can analyze first with the help of a situation. If we draw the figure, we can see the total rod length is 1 meter, but it is a stepped rod in which one length is having an area 5 centimeter square and other length is of area 10 centimeter square. That means if here the area is 5 centimeter square, we can see for the remaining length the area of this rod will be 2s, that is 10 centimeter square. And its total length is 10 centimeter square. So we can say if this length is x, this will be 1 minus x. And it is subjected to a stress for which, say, we apply a force F1 on both the sides. Here, as Young modulus is same for both the portions, we can say as here area is double, the strain in the larger cross section will also get double. So in this situation, we are given that the strain energy in this rod will be 40% of that of a rod of 1 meter in length but having uniform area. Here we can say if there is a rod we consider again of length 1 meter but it is of uniform area, and we consider it is subjected to the same maximum stress which is there in the stepped bar. So here we can write if in this small section we consider stress is sigma and strain here is small sigma, then for the area when it gets double, we can say for the same force the stress reduces to half. So we can write in this situation the stress will be sigma by 2, and obviously as Young modulus is same, here strain will also be sigma by 2. This is the strain and this is the stress in the larger area, and for the smaller area the stress becomes double, and as Young modulus is same, strain is also getting double. And here we are using the same maximum stress which is used over here. So it should be sigma and strain will also be sigma over here. And we can consider it is due to a force F2 applied on this rod. Now in this situation, we are given that the strain energy in the stepped rod, if this rod is taken as A and this is taken as B, so strain energy in A is given as 40%, that is 0.4 times the strain energy in rod B. Here you can consider the symbol of stress we are using as sigma and symbol of strain we are using as a small sigma. Now in this situation, if we substitute the value of strain energy, here strain energy can be written as energy density multiplied by the volume. So here we can write for the first part of this rod, strain energy will be half multiplied by sigma multiplied by small sigma multiplied by the total volume. Its area is taken as S. Then here we can write its volume will be 1 minus x multiplied by s, plus the strain energy in the second part of this stepped rod is half multiplied by here stress and strain can be given as sigma by 2 multiplied by small sigma by 2 multiplied by x and twice the cross sectional area. Now in this situation this should be equals to, here I can write 0.4 times the strain energy of the bar B, where we consider the energy density is half sigma small sigma multiplied by its volume, which is 1 multiplied by twice the area or twice the cross sectional area, which can be written as 2s, as it is equal to this 10 centimeters square given in the problem. Now we simplify this relation. Here you can see the value of half gets cancelled out and sigma will also get cancelled out, and here s also gets cancelled out, and if we simplify this relation, finally we can write on solving we get the value of x is equals to 0.4 meter. That is the result of this problem.